Here's the diagram for the lab we're about to run, and it should look awfully familiar. I've just taken hosts 2 and 3 totally out of the equation. And what I've done here after a write erase and an initialization of the switches is put hosts 1 and 4 in VLAN 14. Host 1 is connected to switch 1, host 4 to switch 2. And we have connectivity right now with everything at its default. Let me move that over just a little bit. And I ran that right before I started recording. Host 4 can ping host 1, no problem. Host 1 can ping host 4. Apparently I can't highlight, but there we go. Host 1 pings host 4, no problem at all. So we're all set there, and what we're going to do then is just disallow that VLAN on one of the switches. We'll do it on switch 2, and we'll do that. How could we do that? There are actually a couple of different ways we could do that. Going to be switch port trunk allowed and the word VLAN. And we could do an accept 14 or a remove 14, because right now, what is the current list? Let's do a quick verification there too before we start a lab with show interface trunk. What is the current list of allowed VLANs? 1 through 4094. So I could do a remove 14 or an accept 14, and either one of them is going to give me the result that I want. So let's do an up arrow there. Let's do another one here. And I'm going to do accept 14. Now we're going to verify that. And you can see that VLAN 14 has been removed from the VLANs allowed on trunk section, because now that says 1 through 13 and 15 through 4094. Note though that the trunks are intact. Switches are generally going to agree on which VLANs they're allowing, because that's what you and I as network admins will do to keep that consistency, but it is not an absolute requirement. It is going to be enough though, I believe, to mess up our connectivity that we had just a moment ago. Let's try pinging host 1 to host 4. And that's never good when you start getting timeouts when you just had connectivity. Now we know why, but let's say that you just came in on the middle of this, or it was a lab and you started it one day, you came back the next day, and it's like, oh, I don't remember why I can't ping from host 1 to host 4. An excellent real-world troubleshooting tip for you. Don't start your troubleshooting at layer 3 of the OSI model just because you're on a router. Don't do it. You always want to start at layer 1, of course, because without the right cabling and the right connections, nothing above that's going to work. But just because you're seeing a problem with pings or anything running at layer 3, don't make the assumption that's where the issue is. Because we know the problem is actually at layer 2. But people do get tunnel vision, I've seen over the years. It's like, okay, if I'm on a router or I can't send pings, the problem has to be at layer 3. And as we're seeing, that's not necessarily so. Let's try pinging 10.1.1.1 from host 4, and we're going to get the same result. Now, this isn't part of your switching study, but what layer 3 command could I use here to get a little more information on what's actually happening with these packets? Because ping is a great place to start, because it'll tell you, point blank, hey, you have connectivity to this IP address, you can't reach this one, but it doesn't tell you why. So we got to go a little further, we got to dig a little deeper, and that usually means a debug. What debug could I run here to get information like that? I like debug IP packet here. I'll give them a little message, and I'm going to send the pings again. Of course, I have to give you the obligatory warning, it's very serious. Do not run debug IP packet in a production network unless you are sure about how much information you're going to get back, because it can really hammer your device if you run that command on a busy network. So here, we see everything we pretty much expect to see. You can tell by the timestamps to the left that the pings are going out every 2 seconds, and the IP address, we know the source, we see the destination, we see sending. If you're looking for the timeouts, for the periods, they're way at the right side here, right after sending. That's not a period ending a sentence. Those are actually the ping timeouts. But the thing is, we're seeing sending. So the packets are actually leaving. In the route and T-shoot courses, we will see situations where the packets aren't even leaving the current router, which is why I like to run debug IP packet. It's telling me whether the packets are even leaving the router in the first place. and they are leaving. Now, what do I need to do before I go to another router and start running debugs for my other host? Because remember, these are Cisco routers I'm using for hosts. And what you should do is a UAll, easy to remember, short for undebug all. Turns off all your debugs. So let's go over to router 1 or host 1 here, and we're going to run debug IP packet. And we're going to see just about the same thing. Of course, the source and destinations are reversed as we would expect, but the pings are going out every 2 seconds, 5 packets every 2 seconds, just the way we expect. They're just not coming back. And again, don't spend all your troubleshooting time at layer 3 when your pings don't go through, because you always want to check layers 1 and layer 2 first. So if our host can't ping, we need to undo what we did on switch 2. Right after I do a UAll. I thought you had me. There's nothing wrong with leaving your debugs on in a lab environment. Just go back and turn them off before you start another lab, because all of a sudden you'll have stuff flashing up on the screen. It's like, where's that coming from? So let's see. Let's go over to switch 2. I'm going to run my interface range command again. And switch port trunk allowed VLAN. What are my options here? What would work? If you were in an exam and you were asked, which one of these 5 options, add, all, accept, none, remove, what could I use here? I could actually use 2. I could do add 14, that's probably what I'll do here. But since 14 is the only VLAN that's been disallowed, I could put all, just allow them all again. But I'll just do add 14. Show interface trunk. And you can see the VLAN is now allowed again, 1 through 4094. Also, under the next heading, VLANs allowed and active in management domain, we see 1 and 14 again, 1 of course being our default VLAN. So let's go over to host 4 and send a ping to 10.1.1.1. Now this may not take place immediately. If I hadn't done show interface trunk and I came straight to host 4 and I'm trying to ping host 1, then it may take a couple of ping attempts before everything is where it should be. You could see the last ping there went through of my ping attempt, and then finally I just sent another one right after that, and they're going right through now. So sometimes these things take a little bit of time to cook, so to speak, and there you go. Just as a quick reminder, let me run debug IP packet here and send the ping. And this is what we actually want to see, because here you're seeing sending and received, and that's what we want to see. Before we were just seeing sending, and that's not good. It's not enough to send, we must receive as well. That concludes this particular lab, and also our look at VLANs and trunking. The next section is related to trunking, very important information, not just for your exam, but for your production networks. It's all about the VLAN trunking protocol, and I'll see you in the next section and the next video.